Hi, thanks for joining me. So today I'd like to just do a quick video here about dumping a script for Stratego. This is an adaptation of a physical board game on the PC Engine. I've been going through the PC Engine library and trying to dump scripts for pretty much all of the games that I can, all of the Who card games anyway. So yeah, this game was a little challenging. It wasn't, crazy, but there was enough things that I thought might be interesting to talk about that I figured we'd take a quick look at it here. So first off, I guess I did, what I would normally do. I went ahead and looked at the ROM in a tile editor, tile viewer, and I didn't see the font. We could go through this whole thing, but just take my word for it. I looked around through here, I wasn't really able to see it. So what that means is that once we find a byte value for a character, we can't just extrapolate from that based on the order that we see the font tiles stored in the ROM. We kind of have to confirm each byte value. So this is, if this is just an 8-bit text encoding, we've talked about that before, but that range of values is 256 values, so that's not too bad. So for one thing is that there's not much video footage of it on YouTube. Like, I don't know if you saw, but basically there's these 34 or 36 second clips for whatever reason, and then there's this one dude who's playing game, but he's playing a whole bunch of different games. He's not just playing Stratego. So if we look at this though, see here, yeah, I think I used this in particular. It says Scout. So I think these are your kind of units. You've got what is this? So it's like Sergeant, Sajin. It says you've got a commander. So I ended up with Scout, wherever it went here. There it is. And anyway, so I decided to search for that. So, of course we're going to go to Translation, which I normally use. I just, again, like I normally do, found a series. And somebody made a comment that was kind of snide somewhere about, how not everyone has a Japanese kana set laying around that's like mapped to hex values, right? It doesn't need to be hex values. Like, write it out in decimal. It doesn't matter. Like over here, if you're going to do your value scan relative, you can do it based on decimal amounts or hex amounts, either one, right? So anyway, so I basically did it this way. Su ka uto, put that in here, and our hit that we got here was this. We've got BD, B6, B3, C4. Okay, so we would do what we normally do. If Su is BD, we would go into I use my table helper that I wrote here, and we're gonna say our usual thing here. What is this? Su is BD, was it? BD. Save that. Go ahead and run it, and we get this. So our starts at B1, goes down to DDDE. So we're gonna go to options, and we can see here's like some text, right? So I'm like, well, let's try to use this. We have something that resembles the text encoding, and maybe we can put our values in here and then print them to the screen. So I used specifically here where it says let's see, board no henko, and I was able to find a match on this no henko, I think. We're gonna go ahead and do a kana search. We're gonna put this in. We need we don't actually know what our our space character is right now, right? That wasn't in there, and I have a feeling our n is not in the right spot, because a lot of times O and n are flipped or are just stored differently, and one's stored somewhere else. So let's go ahead and find that. Hey, that comes up. Okay, good. Okay, so what we're looking for here, so we've got this no, then the next thing is 2O, which is our space, O, so we know our O is in the wrong spot, easy enough to fix. We go ahead and basically just put n in there, and we'll figure out where O is later. Go ahead and save that file. We'll reopen our table file. There's that. But I figured this no hen code, this is, what is it, 1, 2, 3, 4, 5, 6, 7, 8 bytes, right? And I think I'd mentioned before, like with City Hunter, I was saying it was the first time I had inserted values into a game. It's not really the first time I'd inserted them into a game at all. It's the first time I had inserted them programmatically. So the other way to insert values in the game is just to type them in a hex editor like this. So what we're going to do, let's say we want to know what values, like what tiles are loaded if this text routine runs into the 1 value. So we're going to do 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, and I'm just typing those in. So that's half of our like 1 values. Excuse me. So I'll save this. I'll run it once, check those. Then the next time I could just go in and do, 1 8 through 1F. So that's not too bad. It's not a lot of space, and I could try to like just see if there's more space in here. But I just figured those 8, pretty much I made do with those when I actually did this. Okay, and of course I had actually picked a poor example, because the 1 value is actually there's nothing, no like font tiles come up for that. So if you put in the 2 values, what you'll find is 2O is a space. I think we actually confirmed that here between our no and henko. And then we have some punctuation, exclamation point, quotes, pound sign, dollar sign, that sort of thing. So so that's all good. So that's basically what I did actually to fill out the entire table file, right? So we're going to go ahead here. I'll show you the full table. It's this here. So 00 is a break character. 01 is a switch byte. We haven't even talked about that yet. And then we have this punctuation here that came up, and the rest of this stuff. So one thing that's weird. I mean, all this is pretty straightforward so far. Numerals, punctuation, English alphabet, English lowercase alphabet, which is kind of cool. But then, as we're coming along here, so these are the 7s. We've got 7, 8, 7, 9, 7, A, 7, B, 7. Yeah. So at 7B here, right after Z, we have go. Then we have like a small a. We've got. I could show you what it looks like in the game, but it's a dash, and it has this diacritical mark. Sorry, I'm just moving the cursor. It has a diacritical mark here, basically above it, and I thought that was really unusual. Here we have do, and I'm just like, I don't think I need to worry about these, right? So I just kind of went on, and then here we started on what I think of as kind of like the font proper. Okay, so we have actually again seemingly another space character. Periods, this punctuation here, and then we get our O, our small kana, this is like small hiragana, I guess, dash, and then we get our regular full set of hiragana characters. So I thought maybe that was all that we were working with, but actually this particular example that I picked was really a good illustration of what was going on here. The main thing that sticks out is this CE, all right? So CE in our table file is so it's ho, right? But over here we can clearly see in the PC Engine screen that it's bo, right? So it's a katakana bo specifically. So here we have this stuff showing up in katakana, and then we hit this 01, and then we get hiragana, and I was like, this is probably a switch byte, right? So I was like, okay, I get that part. But finally it also dawned on me too that the 7D and 7E here in particular are actually really important. They basically made this dash with a diacritical mark above it, and so visually, your brain is applying that diacritical mark to the character previous to it, but it's not really attached to that character. It's actually attached to the encoding that is 7D. Basically 7D is saying make a diacritical mark, then make a dash. Now, so this is really only significant, I guess, in like how I'm wanting to dump this script and how I'm dealing with diacritical marks. So we'll get to that later. But this is, between those two things, it's a little unusual. I've run across scripts that use switch bytes before, and this is what I would call a toggle switch byte. So the same byte is toggling back and forth. And what I also need to do, because we're using a switch byte, is make a second table file. So our other table file here is the exact same as the first one, so we're keeping all the same values in it, but we're switching our Hiragana values with Katakana. Okay, so that's what I'm assuming is any time that we switch, we're going to be switching to from all Hiragana to all Katakana. It's pretty straightforward, really. So let's go over to my dumping script. Actually, let's go to the notes first. So what I did, of course, is I just browsed through this ROM, and I wrote down all these offsets where I saw text. And sometimes this can be a little daunting, but at the very least, this is like a small ROM, right? And it wasn't too bad. This is only like maybe 30 different pairs of offsets, something like that. So we're gonna go ahead and put that into my script though, because it's a lot easier. I don't want to dump this out into 30 files, and I certainly don't want to do it like individually. So I just put all the script offsets here. We have we have to do our path to our thing. We do our table, and actually I ended up doing table 2 first, and I'll talk about that. We name the scripts. The file name is just going to be text 0 in this case. Yada yada yada. So I decided that I want to merge it, right? So we just have one file instead of 30 different files. And I was prepared to go, okay, if we need 30 different files, maybe we'll do that. But what I wanted this to do is merge. And and then we put in our two tables, table 1, table 2 in this case, and we give it our switch byte, right? So let's go ahead and try running this, and this is what we get. So I was like, okay, yeah, I'm pretty happy. It looks like it dumped the stuff here that we wanted. But let's see how this deals with our switching, right? So we start off here. Let's pretend, for the sake of argument, that this is fine, which actually I think it is. So it switches. We say kono, and then it switches gemu. So that's what we would expect. So this is going Hiragana after it switches, then it's going Katakana after it switches again. And this I would expect to be in Hiragana because it's kind of like Japanese, and then it's saying gemu in like effectively English. It's a loan word, right? So this is in Katakana, then it switches back and it's in Hiragana, then it breaks, then it comes back and it switches again, and then it says yamete mo yoi desu ka. Now I would expect yamete mo yoi desu ka, like, do you want to quit the game, basically. This should be in Japanese, in Hiragana, because it is Japanese. It's not a loan word or anything like that. It probably shouldn't be in Katakana in this case. Some games maybe they have all their stuff in Katakana, but this game, this game doesn't. It has stuff in a mixture of Hiragana and Katakana. So I was like, huh. So then we get down here, single game mode. That seems fine. Then we break, and it switches and goes back into Hiragana. So we're like, okay, ni henko suru. Then it breaks and it switches again, and it says yoroshii desu ka again in Katakana instead of Hiragana. And at this point, I'm getting frustrated. Like, what in the heck does this do? Why does it switch after it's already in Hiragana, right? So I had to think about this for a little bit, and I was like, well, maybe it's significant that it breaks, right? And I'm like, well, so what if we assume basically that there is a default tile set for the encoding, and on each line it starts at the default, and then you have to tell it whether you're going to switch or keep the default. And I was like, okay. So in this case, the default is the katakana, right? Because there's no switch here. So it's writing this out in katakana, which seems correct. Then we move to the next line. The default is katakana. We're going to switch it to hiragana. I'm like, okay. Then we break. We come down here. The default is katakana. We're going to switch it to hiragana, and we're going to print it out. And I said, okay, that seems to follow the logic of this game. So what I had to do is go into my so I've got a library of functions here that I use for my script dumper. So basically the way that I keep this a little bit modular, just to use these config files, is so I basically pass like a whole ton of arguments to this this encode function. So encode blocks basically just pass, all this stuff gets passed to it, and then it works on that data, and then it passes it back as like this array called blocks, I think. So so what I decided that I was going to do is like, okay, I need to find in here where we handle the switch byte stuff. So I searched for switch. It's basically all here, and it's just really simple conditionals. This is what we want to deal with here, is where if switch byte is set basically and switch byte 2 isn't set, is what this is saying, then we're going to use it as a toggle. It's just going to say if current table is table, then make it table 2, else make it table 1, right? But that's not sufficient for what we're doing. So actually I just put in another else if. So I'm saying like else if not if switch byte is set, do this, but if switch byte line reset is set, and our byte value equals the switch byte line reset. So I basically like wanted our switch byte line reset value to be the value of our break character, right? So when we run across our break character, it means that we're going to a new line. If we're just starting off on the first line, it's not going to have a break character, but it's just going to be using the default the initial table. Once we hit our break, we want to go back to the initial table, no matter which one we'd switched to previously. So I just tell it switch it to our default table. It's really super simple, but I didn't have that in there. And then let's see. So then we have to go to script dump, and we're going to have to pass it our switch byte line reset. So I put that in. Switch byte line reset is a thing, and then in our config files we just need to like add that as a constant. So I went ahead and added this in. Switch byte line reset equals, and so basically if the table resets on a line break, then set this to the value of the break character, otherwise it's null. So we need to set it to the value of the break character, so we can go here, look at our table file. Of course, the break character, I believe it's 0. Yeah. So we're just going to copy that, and we'll put that in there. So we'll go ahead and save that. This is our config file. Yeah. And we'll go ahead and run it again. So when we do that, we're going to get a new script called text 0. We're going to reload it, and now this one didn't have a switch in front of it, so we're assuming that the yes and no is supposed to be in katakana. But then we get to our problematic things here. So starting off hiragana, katakana, hiragana, right? Okay, this was the one where it was like not working right. Then we get over here. This is what we were expecting: katakana, hiragana, and that seems to hold up for all of the rest of the stuff here in our file. It all comes up hiragana and katakana correctly. Now that wasn't the only weird thing. I wanted to come back to that weird way that we're dealing with some of this stuff, we have this 1 byte that represents our diacritical mark and our whatever this is, a dash. So so the way that I wrote this, and actually I'm really kind of almost questioning why I wrote it this way now. If I go into here and I say, what is this, diacrit type, so I would call this post. So this is basically, is it before or after the character? Does the diacritical mark come before or after the unvoiced character? So in this case it comes after, so we're calling it post. We hit save. If I go ahead and run that, we're going to run it, and we're going to get our new file and put it over here and reload it, and we're going to see it looks exactly the same, right? So I was like, oh, okay, because what I had it do, and I think maybe it was just easier for me, I literally have it say, okay, find in our table file this value and the value for our little circle diacritical mark there, and then figure out what the byte values of those are in the table file, and then when you run across those, you know, instead of showing just these two things with, you know, this unvoiced character with the separate diacritical mark, put them together and make a single voiced character like you normally would. And that isn't going to work for these, because this value is not our value for just our diacritical mark. It's the value for the diacritical mark with this, so it's a different value, and it's not gonna find it. So in this case, what I decided to do, instead of rewriting my whole dumping script, what I did is, you know, this again, to make this pretty modular, our config files, I basically have this post-process blocks function. So pretty much after I've gotten blocks back, I literally just run this function in my script dump program, so that I can just do any processing that's specific to a particular game in the game's config file, because that config file is specific to the game. And so in this case, I was like, well, let's just replace just the instances of that where we use this weird character to deal with the diacritics. So we've got just 1, 2, 3, 4, 5, 6, 7, 8, and just 9 of them. So it wasn't that bad. I'm like, you know what? We'll just deal with it that way for this, because it's a special case. So let's save that. We'll go ahead and run it again. We'll bring our file up, and we can see there, Gameu, just like it's supposed to be. But anyway, so we're going to look for it, and actually, so I can look for it all day long. This is the only other instance of it. So there's one spot here where it seems like it definitely uses this dash with the diacritical mark, but it uses it in a spot where they should have used like this dash here, the regular dash. No idea why. I would call it a typo. I assume in the real game it comes up. So this is Apache. So I think it is Apache, right? Like the helicopter or something. This is tank here. Or I mean, it could be the Indian tribe too, I think, but I don't think that's what they're talking about here. You would say that without any sort of diacritical mark here. It's super weird. So you know, I had to just confirm. I was like, okay, am I missing any of these instances? And I'm really not. But there's just this funny spot where I think they just literally used the wrong dash and never caught it. So yeah, so we have a good script for this. You know, it's not big, it's not long. It's all like basically menus, right? This should be all of the text. I just eyeballed it, so maybe I missed one little block of text in the game, but hopefully I did not. And this is the whole thing. But I'm a little proud that I was able to kind of figure out that we would switch based off of like a default encoding for each line, not just. I mean, it seems a little weird that when you're printing a set of lines that you wouldn't just sort of like go off of the the encoding that you were using from the previous line, but that's actually not how it works. So it's pretty weird, and there were just a couple little idiosyncrasies about this. I thought that you guys might find that interesting. It's only a 9K text file. So I guess that's all. Thanks for joining me. I'm sure this was not nearly as short as I thought it would be. I hope it was interesting, and I hope you guys will catch me next time. Take care.